SpaceX has one shot to make 2026 work. Flight 12 will debut the completely redesigned Block 3 Starship, new Raptor 3 engines, integrated hot staging ring, and a booster built from scratch. If this mission fails, everything stops. No orbital refueling, no rapid reusability, no Artemis timeline. But here's the pressure. The FCC permit says April for Flight 12, yet SpaceX scheduled their full ship-to-ship refueling test for June. Can they validate an entirely new rocket generation in just 2 months? And what happens to those ambitious 30 to 50 launch predictions if they can't? Let's find out on today's episode of New Space Review. Flight 12 isn't a simple upgrade. SpaceX threw out the Block 2 design and started from zero. Booster 19, clean sheet redesign. Ship 39, same story. When engineers say clean sheet, they mean everything. Structural design, manufacturing process, system integration, rebuilt from scratch. The Raptor 3 engine sits at the heart of this redesign. Each one pushes 280 tons of thrust while weighing 25% less than Raptor 2. The specific impulse hits around 350 seconds, which means better fuel efficiency across the board. But SpaceX removed the heat shield from these engines completely. Why strip out thermal protection? Simplicity. Fewer parts, fewer failure modes. But now those engines must relight perfectly during re-entry. No second chances. That's what makes Flight 12's engine relight test so critical. If those Raptors don't fire on command, Ship 39 can't do controlled re-entry. No catching attempts, no reusability. Flight 13's orbital mission stays grounded until Flight 12 proves the engines work. Now, hot staging has always been violent. You're igniting the upper stage while it's still connected to the booster. Previous versions used a bolt-on ring that added weight and needed installation before every flight. Block 3 builds the hot staging ring directly into Super Heavy's structure. It's part of the methane tank now, not an attachment. Those triangular vents you see? They're not decoration. They channel exhaust away from critical hardware during separation. 3 benefits hit immediately. Less stress on the booster, 0 installation time, and 10% more payload capacity. That 10% matters more than it sounds. Each tanker flight carries more propellant to orbit. Fewer flights needed to refuel a moon-bound Starship. Lower costs, faster turnaround. This one change could decide whether SpaceX meets the Artemis 3 deadline or misses it. The new grid fin setup ties into this. 3 larger fins instead of 4, positioned lower to match the catch arms. Super Heavy needs to be caught, checked, refueled, and launched again within days, not weeks. That's the goal Block 3 needs to prove. Ship 39's heat shield uses something SpaceX calls crunch wrap sealing material. Weird name, serious purpose. Plasma sneaks between tiles during re-entry and burns the structure underneath. The new material seals those gaps better and speeds up maintenance between flights. But the bigger change is how they're building the ship itself. The old way stacked horizontal rings, weld each ring to the next, creating weak points all around the circumference. Block 3 uses longitudinal construction. They roll large steel sheets into tubes and weld one vertical seam down the side. Fewer welds, and those welds align with flight forces instead of fighting against them. The nose cone takes the worst punishment during re-entry. temperatures over 1,400 degrees Celsius, while aerodynamic forces try to tear it apart. Stronger construction means Ship 39 survives multiple re-entries without major repairs. And that's the only way rapid reusability works. There's a manufacturing angle here too. Fewer welds mean faster production. SpaceX already has 10 ships in assembly. If this construction method works on Ship 39, every ship after benefits immediately. That's how you go from a handful of flights to dozens per year. Despite all these changes, Flight 12 follows the same trajectory as Flights 5 through 11. High arc, 200 to 300 kilometers altitude, controlled splashdown. Some people think that's too conservative, but it's actually smart. SpaceX needs clean data on Block 3 performance before pushing further. If they tried orbital insertion and catching on Flight 12 and something failed, they wouldn't know which new system caused it. The proven flight profile lets them isolate variables: Raptor 3 behavior, hot staging performance, structural integrity, heat shield effectiveness. Each data point feeds directly into Flight 13's configuration. A failed ambitious mission costs months. A successful conservative mission that collects good data enables faster progress afterward. SpaceX learned this with Falcon 9. You build confidence incrementally, then accelerate hard. The Raptor 3 testing on Flight 12 also sets up future refueling missions. Engine performance in vacuum, restart reliability at different propellant temps, thrust control precision. All of this needs validation before SpaceX tries transferring hundreds of tons of cryogenic fuel between two spacecraft in orbit. While everyone watches the rocket, Pad 2 makes its debut with Flight 12. This isn't just a backup launch site, it's everything SpaceX learned from beating up Pad 1, implemented from the start. The foundation uses stainless steel framework filled with concrete instead of traditional concrete with steel cladding. It stands 1.5 meters taller than Pad 1, already planning for bigger boosters down the road. The chopsticks are 10 meters shorter, which seems backwards until you realize lighter mass means faster response during catches. When you're grabbing a 200-ton booster out of the sky, milliseconds matter. Pad 2's launch mount looks completely different. Large cuboid frame instead of Pad 1's donut shape. Still has 20 hold-down arms, but redesigned for more strength. The water-cooled steel plate on top builds on what they tested at Pad 1 during Flight 2, just way more refined now. The real upgrade is the integrated flame trench. Pad 1 deflected exhaust outward from a flat plate with water sprays shooting up. It worked, but barely. Pad 2 pushes exhaust down into a trench, where high-pressure water jets from multiple angles cool everything fast, while cutting noise and vibration. The deluge system delivers about 422,000 gallons at serious pressure. Jets hit the main plate, trench walls, central ridge, everywhere. When 33 Raptor 3 engines fire, over 9,000 tons of thrust, this system handles it all. But here's what really matters. Pad 2 can recycle water between launches. Same-day relaunch attempts become possible. SpaceX needs this to hit their 2026 numbers. If they can flip a pad in hours instead of days, the launch rate jumps significantly. So here's what it comes down to. Flight 12 validates everything SpaceX plans for 2026. Raptor 3 relights, integrated hot staging, longitudinal construction, Pad 2 operations. One flight proves or breaks all of it. Block 3 works. We're looking at 12 to 15 launches this year, maybe more. It doesn't? Those big predictions turn into careful delays. One mission controls everything. SpaceX put their entire 2026 timeline on getting Block 3 right the first time. Want to stay on top of Flight 12 and everything Starship? Subscribe and hit notifications for new space review. Drop your 2026 launch prediction in the comments, 10 flights or 30. Share this with anyone following SpaceX. Ready for more? Click the screen now for It's Mind-Blowing, Starship Flight 12 revealed. V3 debut sooner than expected. We've got details you won't find anywhere else. Thanks for watching. This community is why we do this. See you next time.